So good day, everyone. This is example 6 on Kirchhoff's rule. In my previous class, I stopped at what? Example 5. So like I said in my previous class on Kirchhoff's, I said I'm going to give you nothing less than 10 questions on Kirchhoff's what? Rules, application. So the way we solved yesterday or in my last video, we are given the EMF and the resistor. We have to find currents. So in this time around, we are given current and resistors. We have to find what's EMF. In the same procedure. Let's go. Solution. So the first thing that you need here to do is what? You will need to locate the direction of the what? Direction of current. You will observe that this is the what? The current always starts from positive what? End of the battery. So this is what? Where the current is coming from, like this. This is I2. Get to this point, the I1 and I2, they meet at what? At this junction, and they give us what? I what? I3. When we get to this point, what? This current go back here, this one also go back here. So this is also what? Another what? Load. So we cannot say from Kirchhoff's, from Kirchhoff current law, saying that algebraic sum of currents or sum of currents going to the what? Junction, entering a junction equal to the what? Sum of currents that leaving the what? The junction. For this expression now, the I1 and I2, they are going to the junction, while what? I3 is leaving the junction. So you can now say what? From this expression, that I1 plus I2 equal to what? I3. Equation what? Equation 1. But don't forget, we are given that what? I1 is 0.5. Put it here, is 0.5. What is I2 given? I2 given is 0.2 equal to the what? I3. By sum the two together, I mean, like we now have what? I3 should be 0.7 ampere. That is what? The current of what? I3. So the next thing that we need now is what? Let us deal with Kirchhoff's second law, which is voltage law, or law of conservation of what? Of energy. So the law states that is what? The algebraic sum of what? Of voltage is equal to 0. And say what? From Kirchhoff voltage law, we say that is what? Algebraic sum of voltage at a what? A loop is equal to 0. If you say that, this is the positive end of the battery. For the resistor, polarity of resistor, positive, negative, positive, negative, positive. No. For this one, current is coming like this, positive, negative. Current is going like this, positive, negative. Current, positive, negative. How to determine the polarity of resistor? I've explained that one from the beginning of the what of Kirchhoff's law. So if you missed the video, go and check it. So to know how to determine the polarity of what? Resistor. So by taking the loop, now say what? From or for loop A. We have two loops here. This is the first loop, this is the second loop. If I take the loop of the first cell like this, and I call it what? Loop A, the first loop. So it will not take our loop from what? E1. So the E1 will be positive. Then what happened to this? Yes, in this case, these 4 ohms and 2 ohms, they are parallel connection. Add the two together, they will serve as what? As R1. So this is their current. That's only it what? Minus V1, because when it's going like this, the voltage drop here too. So the 2 and 4, the voltage drop, they serve as what? V1. Then this one, current I3 that is coming here, this 9 ohms, serve as what? V3. It's also what? Drop, voltage drop there, minus equal to the 0. So this is E1. We have E1 here. This V1, it should be what? Current I1 and R what? R1. And this will be what? Current I what? 3 and R3 equal to 0. But in this, at this junction, this E1 is this minus the current I1 given is 0.5. 0.5 is the current I1 given. Don't forget again that is what? This current I1 pass through the what? 2 ohms and 4 ohms. They are series. Combine them together, we have 2 plus 4, 2 ohms plus 4 ohms. So the two of them will give us what? This minus I what? I3. Current I3 is 0. What? 0.7. What is what? The resistors for the I3 is 9 ohms. We have what? 9 ohms. Everything equal to what? 0. Good. So this is 9 ohms. This is current I3 that we get here. I put it here straight. So from there, we have what? E1 should be what? Minus 0.5 into what? 6. Then 0.7 multiplied by what? 9. 0. What? 0.7 multiplied by 9 to give us what? 6.3 minus 6 point what? 3. Everything equal to 0. Here we have E1. 0 times this, we have 3 ampere minus 6.3 equal to 0. So you now have what? E1 minus 9.3 equal to 0. The E1 later give us what? Minus 9.3 volts. But you are now asked to approximate to the nearest whole number. By approximate to the nearest whole number, I think we have E1 will be what? Will be 9 watts. Will be 9 ohms. E1 will be what? 9 ohms. I can now say what? Therefore, E1 will be 9 watts by approximately 9 volts. So, the next one is what? Let us find the E what? E2. To know the E2, we are going to take the loop from this side, like this. This is the loop, loop B. So can I say what? For loop what? B in the circuits. By taking the loop from B, if we hold that what? The loop started from here, this side will be what? Positive, negative, going like this. It should be E2. Then the voltage for this, you know, we have 4 and what? 6. The same current pass through them. They are in series. You add them together. So can I say what? Minus V what? V2, because the voltage drop here, then it's going like this. Here, from positive to negative to voltage what? Also what? Drop to be minus V3 equal to 0. So E2 equal, what is V? Will be I2 equal to what? R2 minus I what? I3 equal to what? I3 equal to 0. So the E2 is this. What is I2? The current I2 given from the question will be equal to the what? Is 0.2 bracket. The R2 are in series 4 and what? And 6. Because the same current pass through them, you will add them together. So by adding them together, what am I going to have? 4 plus what? Plus 6. 4 plus what? Plus 6 volts, Abi. Then minus R3. R3 current is what? R3 current is 0.7 is 0.7 into bracket what? What is the resistance for R3 is 9. 9 ohms is the resistor for R3. Everything equal to 0. So the next thing that we do is what? I cannot say that we have E2 should be equal, minus 0. What? 0.2, 6 plus 4. It will give us what? 10. Am I right? Yes, 6 plus 4 will give us what? 10. And minus 0. What? 0.7 into what? Into 9 equal to 0. So let me press the calculator. What do we have there? 0.2 multiplied by 110 is 2. I have 0.7 multiplied by 9 is 6.3. So here we have what? No. Here we have E2 minus 2 times 10 is 2. Here we have 6.3 minus 6.3 equal to 0. We have E2 should be minus 8.3 equal to 0. The E2 will be give us what? 8.3 volts. But we are asked to approximate to the nearest or what? Number. So it will be what? 8 volts. So that is what? The final answer for what? For the question. So let me help you to let me add 3 more questions to this. Let's try this example 7. Look at question 7 here. Solution. So let us locate direction of the current. This is 10 volts, 12 volts. The current starts from there. This is junction. The current come here and the one go here. So this is the current that come here. We call it what? I1. The current we have here, let's call it I what? I2. The current here is what? I3. Abi? Yes. Yeah. From that, you can say from using Kirchhoff current law, we say that what? The sum of the currents leaving the junction equal to the sum of the currents entering the junction or the sum of the current leaving the junction. So the I1 go to the junction, I2 and I3 leaving the junction. We have I1 equal to the what? I2 plus what? I what? I3 equation 1. So the next thing that we can do is what? From using KVL, Kirchhoff voltage law, algebraic sum of voltage in the loop is equal to the what? 0. So by doing that, we can, this is the direction of the current. I can take my loop along this direction. This is loop what? Loop A. This one will be what? Loop B. Take it along these two direction. This is loop B. So what happened to the loop? Now, it will start your this thing for 12. What do we have there? We have 12 volts. Or yes, directly. Let's also be directly, please. This is example 7. It will be 12 volts. This I1 and its resistors. It will be what? Minus 2I1 multiplied directly instead of using V. Out of this I2, the I2 is going like this with voltage. Voltage here will be what? Will be drop. Will be minus 10. And here, I2 with this, it will be positive, it will be negative. It will also drop minus 1 I what? I2, everything equal to the what? 0. Yes? Everything equal to 0. And what we do here? We have this together. 10 minus 12. We have 2 ohms minus 2 I1. This is what? Minus I what? 2 equal to 0. Collect the like types. 2 equal to what? Plus 2 I1 plus I what? 2 equation what? 2. This is equation 1. The next thing that we can do now is what? Let's take the loop B for loop B with the second loop. If like, I can start my what? This thing from 10 volts here. This is positive, negative. It's going like this. The voltage rise. It will be 10 volts. To get to this side, this I3 supply current to the 1 ohm, 2 ohms, and this 1 ohms. You add these two together with I3 minus I what? I3 into bracket 2 ohms plus 1 ohm. Because the two, they have the same currents and they are in series, you add them together. So if yes, then going back like this one is going up. It should be what? Rise plus what? I2 into bracket this 1 ohm resistors equal to what? 0. Rearrange it. We have 10 minus 3 I what? 3 plus I2 equal to 0. What are we going to have here? Is let's substitute for I3. What is I3? From this equation, Substitute for I3. Can say what? Uh, yes, for I3 from equation what? Equation 1, where we have I1 equal to the what? I2 plus I what? 3. So therefore, the I3 here will be the I1 minus I what? I2. Let us put it here. I want to remove the I3 from my equation. And we left with 10 minus 3. What is I3? I1 minus I2 plus I2 equal to 0. Will be 10 minus 3 I1 plus 3 I2 plus I2 equal to 0. Add it together. 10 minus 3 I1, this plus 4 I2 equal to 0. You now have what? 10 equal to what? 3 I1 minus 4 I2. You can call it what? Equation 3. So from equation 1, let's make I2 the subject of the formula. Make I2 so the formula from equation 1 what? From equation what? Equation 2. I2 will be what? 2 minus 2I1. So let us substitute for what? I2 here. By substituting for I2, what are we going to have? Substituting for I2. Substituting for I2 in equation what? 3. Let me start say what? Therefore, substitute for I2 in equation 3. By substituting for I2 in equation 3, we will have 10 equal what? 3I1 minus 4. What is I2? I2 is what? 2 minus I1, I3. Yes, from this equation 1, we now have 10 equal to the what? 3I1 minus 8 by expand plus 8I1. Adding it together, this will go here. We have 10 plus 8. Then we have what? 8 plus this, we have 11I1. Here we have 18, 11I1. So the I1 will be 18 over 11 and what? Ampere. If you press calculator for it, what are you going to have? 18 divided by what? 11. It will be what? 1.64. So I1 is 1.64 ampere. That is for I1. And let's say what? Let's substitute for, let's say what? Substitute to equation 2. Let me call for this. You can call this one what? Equation what? 4. And let's say what? Substitute what? Substitute again. I don't want to use blue marker. Substitute for I1 in equation 4 above. So where the equation 4, I2 is equal to 2 minus 2I what? 1. You now have what? I2 2 minus, yes, 2 multiplied by what? 1.64 ampere. We have I2 2. I2 will be what? Minus 2 minus 1.28. 1.28 ampere. So you can get minus. I said this yesterday. As your answer is depend on the direction of the what? Of the current. And the next one is to know the what? R3. So what will be the R3 here? The R3 for the question from equation 1. We know I1, I2, R3. What is the R3 now? You can say from Kirchhoff's law, equation 1. Have you now? Here. As we know that what? I3 is equal to what? I1 minus R what? R2. Check it here. From this expression, this to this. So what is R1? I3 equal to I1 is 1.64 minus 1.28. Everything in ampere. Subtract it. Give you minus 1.28. So the minus times minus to give us plus. You have R3 should be equal to what? 1.64 plus 1.28. The minus in the middle here will cancel this. At the end of the day, 1.2, it will give us what? 2.6. Give us 2.91. I3 equal to the what? 2.9 watts, 1 and what? Ampere. Those are the what? The current I1, I2, and what? And I3. Let me give you the last question, which will be the what? The complex one that will comprise of 3 loops. This one is loop AB, so we have 3 loops. So this will be the example 8, if I'm not mistakenly. Example what? 8. Solution. They are asked the first solution. Let me put it there. Then there is no need. The question from the sketch is you are asked to what? To find the current that is what? Flow in each resistor. If you look at the circuit, we have how many resistors there? 1, 2, 3, 4, 5. So we have 5 or what? Unknowns. So each resistor must have its own what? Current. So in this case, this is a complex question, complex circuit. So we are looking for the 5 currents here. So we have how many EMF? 5 and 10. So the first thing that I will do is what? I will locate the direction of my current by the direction of the current. So this is the current I1. Get it to this junction, the current split. It split to what we call what? This is current I2. Let me call it what? I what? Or let me put it here, I2. and the current splits from here, and the second one go like this. Know that is going here, we call it current what? I3. You can observe that what? This current I2 supply current to this 1 volt, 1 ohms. This current I1 supply current to the what? 2 ohms. This current I3 supply current to the what? 1 ohm. And this I3 get to this point. This same I3 splits at the junction into 2. Like this. This one, we can call it what? Current I what? I4. And this thing also to the what? Current I what? I5. Like this. So, this question is the same thing with the one that I did before. Just compare to 3 loop. So, the first thing that we do is from Kirchhoff's, from Kirchhoff current law at junction X. This junction X. Here we can have that what? This I1 split to what? I2 plus what? I3. Junction X. We call it what? Equation what? 1. Because we have 5 unknown here. So our equation must be what? Must be 5. If we have 2 unknown, the equation must be what? 3. 2. If we have 3 unknown, the equation must be what? 3. This is equation 1. Let me use the red marker to signify this X. This point X. This is what? Point what? Point Y. So, you can now say what? From KCL at junction Y. What is junction Y? This point. The I3 is going in, I5 and I4 leaving. We can have what? I3 is equal to current I4 plus current I what? I5. This is equation what? Equation 2. If you are done with that, the next thing that we need now is now need to take the loop of the circuit. Take the first loop here, like this. Let me call it what? Loop A. So let's take the what? The second loop here. This loop what? B. Let's take the what? The third loop here. This loop what? Loop C. So let's take it one after the other. Let me say from loop what? A. From loop A in the circuit. If we want to take the loop from A, we have how many things here? 10, 2 ohms, and 1 ohms. If you are taking the loop of what? Of B, we have what? 5 volts, 1 ohms, and 2 ohms. Taking the loop of C, we have what? 2 ohms, 5 volts, and these 2 ohms. So for this one now, how many things are involved here? 10 votes, 2 votes, 1 vote. And don't forget your polarity of this. This place is positive, negative. This is positive, negative, positive, negative. Mhm. By taking the loop of A, what are we going to have now? For A, you have what? 10 to this one, give us what? Minus voltage drop, 2 current I. This is what? Voltage drop minus 1 current I2 equal to 0. We all know that the loop, so equal to 0. What we do now, we know that what this loop is what sum of voltage at a loop is equal to 0. That's what I did here. So we can now have what 10 will be equal to what 2I plus 1I2. We can call this one what? Equation what? Equation 3. What is the next loop? B. You can also say what? From loop B, sum of voltage equal to the 0 in the loop. Oh yeah, in this B, let's start from here, going like this and going back like this. Start from the 5. Note that this is positive, negative, positive, negative, positive, negative, positive, negative. Yes, when it's coming like this now, it should be what? It will be drop. You know, we take the loop, it's going like this to positive. The loop is what? Is going to negative. Here will be our what? This will be minus, this will be plus. So let me start my loop from here. This cell, which is 5 volts. So the loop is coming like this now, going like this. This is minus. So you will now call it what? Minus 5. Note, when we start our loop from 10 volts here, we have positive. That's why we call it positive. We start my loop traveling from 5 volts. What do we have there? Negative. That's why I put negative here. So after that, it's come to the 1 ohms here with current, the voltage drop minus what? 1 I3. This 1 ohms times I3, 1 I3. Then at this junction, it's come like this. Current I4 with this. It's also drop to be minus 2. The current for this 2 is what? I4. Current I4. And after that, it's going to this side, 12 volts. Yet from positive to negative, we have what? Plus 12 volts, 12 volts. Then after leaving the 12 volts, it's going like this. Then voltage what? Rise. It will be what? Plus 1 I2. Everything equal to 0. So by adding it together here, 5 minus 12, or 12 minus 5, it will give us what? 7. So we have I2, I3. This, you are left with what? I3, this I2 minus 2 I4 plus I what? I2 equal to 0. So this expression, I can change it to be like this. 7 equal to what? Current I3 minus plus 2I4 minus I2 everything is minus I2 to be like this. This will give me what? Equation what? 4. Now I said we are going to have how many equation? 5. So for loop C, the sum of the voltage is also equal to 0, the one we did there. This is loop C. How many loads do we have here? We have 2 ohms, we have 2 ohms, we have 12 volts. Let me start my what? My reading from here. This is also what? Positive, negative. So this 2 ohms will be what? Drop. Have you now? If I start from here, 2 ohms. 2 ohms is what? 2 ohms I5. This 2 ohm, the current is I5 and its drop, it will be minus. So then move to this side, 2. The 12 will also what? Minus. It will also what? Drop. And I write this is what? It's rise. It will give us what? 12. Abi? When it's going like this is 2I. It will be what? Plus 2 what? I4 equal to 0. From this expression, we can have what? Minus 12 should be equal to what? Minus 12 should be equal to 2I5 minus 2I4. Let me call it what? Equation what? Equation 5. So, it's equation 5. The next thing that I will advise us to do is what? Let us reduce this equation to what? To 3 equation. Can I say what? Reduce the equation to 3 equations by elimination I1 and I3. Yes, by eliminating what? I1 and what? I3. So let us do that. For equation 1, we want to eliminate I1. Abi? So in equation 1, what is I1? I2 and I3. Yes? I1 and what? I3. Abi? You can now say what? From equation what? 1, I1 is equal to the what? I2 plus I what? I3. So let's say what? Substitute for I1 in equation 3. So by substituting for I1 in equation 3, what do we have in equation 3? This. We have what? 10 equal to what? 2. What is I1? It's I2 plus I3 plus I2. don't expand yet. Again, from equation 2, I3 is equal to what? I4 plus I5. Substitute for I3 here. To have 10 equal to what? 2 into I2. Substitute for it plus I4 plus I5 plus I2. No, we want to eliminate I3 and I1. That's why I replace this I3 by this equation 5. So by putting it there, we have 10 should be 2I what? 2 plus 2I4 plus 2I5 plus I2. If we add everything together, we have 10 should be how many I2? 3. 3I2 plus 2I4 plus 2I5 equal to what? 10. So if we have it in this form, it will be equal to what? 10. And we can call this one what? Equation A. We want to reduce this 5 equation 1, 2, 3, 4, 5 to what? 3 equation. This one will be what? Equation A. We have 3 unknown now. The next one is in this equation 3. May I have 7 equal to the what? I3, I4, I2. We are eliminating I3. So the I3 is what? Is this. This is the what? The derivation for I3 from this equation what? 5. So we can now say what? Substitute for I3 in equation what? Equation 4. By doing that, we have 7 equal to what? What is I3 there? This is I3. Here, put what? I4 plus I plus I what? I5 to replace it plus 2I4 minus I2. Add it together. 7 equal to how many I4? 3. 3I4 plus I5 minus I2. Abi? I2, 3, I5, 7. We can call this one what? Our equation what? Call this one equation what? B. If this is A. So the last one will be equation this. This one, do you have any I3 and I2 there? No. Equation, this one is still remain here. Minus 12 equal to what? 2I5 plus minus 2I what? I4. This expression serves as what? New equation what? C. So, if we solve this simultaneously, we get I2, I1, 3. From this expression, this equation, this one, let me call it 4 yet. Let me divide both sides by 2. Yeah. By dividing both sides by 2 here, what am I going to have? I'm having minus 6 equal to the what? I5 and what? Minus I4. From this expression, let me make I4 the subject of the formula. So by taking I4 out here, I4 is the formula. Now I go to have I4 here will be what? I4 here will be I5 plus, yes, let me say this is equation what? C. Yeah. From this one, if I bring that here, so plus 6. So this is what? I what? I4. Let me call it what? Roman equation, Roman. Yes, let me, okay, this is what? I what? I4. Let if we substitute for I4 here, if I substitute for I4 in this expression, is if you substitute for I4 in this equation what? This. So you will eliminate I42. You now have what? I5 and I what? I2. So, or we can use what? Determinant of Maxwell-Cramer's rule to solve this complex what? Equation. Because of the time, so I will just help you to what? To write out the what? The final answer out. So, for the current, if you check it, at the end of the day, by solving it, you have current what? I2 should be I2 should be end up to what? 2.25 ampere. Where what? I4 will end up to be what? 3.81 ampere, and I what? 5 will be minus 2.19 ampere, and the I what? We know that I3 is sum of I4 plus sum of I5. Add it together, we have 1.62 ampere, and the I what? I1 is I2 plus I3. It will give you 3.87 ampere. So please, if you solve it furtherly, this is what you are going to arrive to. You have to save time. It's just simultaneous equation of 3 words unknown. Let us look at this example 9. Is differ from others. 100% differ from others. So this kind of question is very common in a multiple choice question, like Jamb exam, or CTME exam, 100 level, and Jupeb exam. If you are given this kind of diagram in your exam, you are asked to find the potential difference between the points what? A and what? And B. These points A and B. And we are given the current flow in the circuits is 2 amperes. We are given resistors 2 ohms, potential difference in the battery 3 volts, resistor here 1 ohms. P is the potential for B. You are now to find the what? Potential difference between A and what? And B. So before we can solve this kind of question, let me give you the clue or the code to it. Yes. Let me list the code here. Mm, let me call it case. Case 1. This question is also the application of Kirchhoff voltage what? Law, second law of Kirchhoff's. For this case 1, whenever you are given this kind of diagram, like this, and this point is what? Is point A, this is point B. Here we have potential difference of what? Of A. Here we have potential difference of what? Of B. Abi? And the current in this circuit is flowing along this direction. This direction of the current. Do you know that what this is what? Resistor. And I've taught you the polarity of resistor. Abi? Current is moving like this. The charge resistor here will be plus, here will be minus. Good. So you are now asked, you know that is what? The current is flowing to this resistor. So the potential difference drop in this resistor here, potential difference drop in this resistor here, let me call it what? V equal to what? I R. The current here times resistor here, that's potential difference drop here. And you are now asked to find the what? Potential what? Difference between A and B, Abi, by taking the what? Kirchhoff voltage law. It's not as what? We change, we apply it. Did you see that what? Sum of what? Of this is equal to the what? 0. Apply it here. By applying the what? The Kirchhoff rule here, what are we going to have? We are going to end up to this. It's here now. Up to this. The take your look from here. This is VA. So VA is positive. And across this voltage here will drop. We have what? Minus V of resistor. VR will be equal to what? Or it will be equal to this. Or we can say what? Minus, let me put it that way. Or let me say is equal to what? Potential difference of B. Why this is minus? This is the current. It's flowing like this. Whenever direction of your loop, I took my loop like this, and the current are the same, the resistor will be negative. So here you now have what? What are we going to have here? We have V what? A minus IR equal to what? VB. You now have potential difference of A minus potential difference of B equal to what? IR. That is the potential difference for this kind of what? Circuit. When the current is felt the same place with what? With loop. But the second case, case what? Case 2. If we have a circuit in this form, and this place is A, this place is B, this is VA, this is V what? B. And the current, assuming the current is what? Is facing the what? This side. So where the current is facing this side, this is the what? My resistor. Abi, don't forget, we still have what? P equal to the what? I what? IR. Abi, so the potential difference here for what? For A, it will now be what? A VA. This the current is going like this, and loop is like this. Is that what? This one will be what? VA. Am I going to put it to? what? VA plus VR will be equal to what? VB. So change this to what? You now have VA minus IR equal to the what? V. So potential difference between A and B will be what? Plus I what? I R. Supposed to be minus. Yes, here will be R plus. Add them together. Supposed to be what? Minus. If this one, yes, come to this side, the minus. Here we have minus I what? I have. So when the current is facing what? This side. So the next one for case 3, if you have a terminal like this, and we have what? VA, VB, which is A, B, no. This one, let me say, is for cell, for battery. We have, yes, for cell or what? Battery. Good. Let me take it for what? For cell, which is what? Battery. This is EMF of the battery, and the current is flowing like this. Along the direction is the current is flowing. So what will be the what? Potential difference? The potential difference here will be also what? Will be also what? VA minus E equal to the what? VB. You now have VA minus VB to be what? E of the battery. If you're asked to find the what? Here. But the next one is case 4. This case 4 is also for battery. If the battery is in this side, we have VA and we have VB. We are now have A here, we have B here. This is E. So we are now asked to find the what? The E what? E VA will be plus E equal to the what? VB. So potential difference of A and B, it will be minus E. Please, for any kind of question like this, we will apply this to solve it. Oh yeah, let me apply it here and solve this question. What? Solution. This is the current. The same current pass through this side. Abi? So what we do now is what? You can say that VA is going like this. Abi? When it's going like this, what happens? The voltage drop here will drop. This will now be what? Minus V velocity, the potential difference of 2 ohms, these 2 ohms here, minus potential difference of what? Of battery, this, then minus what? Potential difference of what? Of 1 ohms, everything equal to the what? Potential difference of B. So this VA, what is this one stand for? It will be what? This current times 2. Abi? I what? I have. Abi now, I can call it what? Current I2 and R2. minus battery. What is the battery here? Is what? 12. Abi minus this one, say current I1 and R1 equal to what? VB. So the VA here, the current here is 2 times resistor 2. That will be 2 multiplied by 2 minus 12. Then current here is current as what 2 here is 2. But that is 1. Is 2 times 1 equal to what? VB. So we have what? VA minus 4 minus 12 minus 2 equal to the VB. Where will I get this bar to be? Is 3 volts. Where will I see 12? Huh? Sorry. No, this part is B. It's 3 now. Where will I see 12? It's 3. It's 3. 3 for this EMF here. So by adding it together, VA 7 minus 9 VB. So VA will be equal minus VB equal to plus 9 volts. What is the right answer? Answer is what? Is this. So let me give you more questions here to solve. Let me say example 10. Calculate the potential difference V minus Q between the points P and Q in the circuit below. Mhm. What's the matter? It's happening okay. Let us look at this question. The current is flowing like this. What will be the what? Potential what? Difference. So, if current is flowing like this, by taking the loop, what? Solution. For this kind of question, we will have what? VP. Then voltage for this one. What? Rise. Voltage for it will what? Rise. It will now be what? Instead of minus, it will be plus I voltage of 3 ohms. These two are supposed to be what? Now here we subtract this one to be also what? Rise plus electromotive force for 20 volts. Yes. Plus, what are we going to have there? Voltage for 1 ohms. Then plus 12 EMF. EMF for 12 volts. Then we have plus voltage for 4 ohms. Everything equal to the what? VQ. Where by simplify, this will be I what? I have. Abi? It will be I what? I have. Change it to the I3, R ohm 3 plus 20 volts plus I1, RR1 for 1 ohms plus 12 volts. This will be what? Plus I4 and R4 go to the word VQ. So what we have next? VP will be this plus what is I? I is 5. 5 multiplied by what? 3 ohms should be 15. Then plus 20, no, 20 plus 12, add it together. 20 plus 12 to give us what? 32. So plus what is I? I is what? Is 5. I is still giving 5. Multiplied by 1 ohms. Then plus what is I? I is still giving 5. Multiplied by what? 4 what? 4 ohms equal to the word VQ. Adding it together, VP be equal, no, plus 15 plus 32 plus 5 plus 20 equal to the what? VQ. By adding this together, this plus this give us what? 20 plus this 40. We have potential difference of P. 40, 20, 40. It gives us 72. What? VQ. Then potential difference between P and what? Q equal to the what? Minus 70 what? 72. So this is how what? We solve this kind of question for Kirchhoff's second law. So it's like we are done for anything Kirchhoff's.